While it's true that mutations can sometimes create new traits, they generally only work to destroy existing traits and information. So, when a new trait called sickle cell anemia arose in Africa, it allowed people to survive malarial infections. It was a new trait, but the hemoglobin gene was broken in the process. Likewise, many examples of antibiotic resistance of bacteria deal with broken genes for transporting things into the cell. The reason that the bacteria can live is because the transporter gene is broken, the poison can't get in. It's easier to break something than to create something new. Natural selection plus mutation actually works in the wrong direction for evolution. So the question is, how does evolution work?
Imagine a bacterium as a very complex machine with thousands of complex processes going on that keep it alive and active. Antibiotics disrupt this complex machinery, for example by interfering with its metabolism, slowing down their growth significantly so they are less of a threat. Other antibiotics attack DNA and prevent it from being replicated, which stops bacteria from multiplying, ultimately killing them. Or by simply ripping the outer layer of the bacteria to shreds so that their insides spill out and they die quickly. All of this without bothering body cells.
So this is the cover of Nature when it was one of the first papers that we published on phage. And in this case, we were killing anthrax, got the most publicity of any publication this university has ever received. Yeah, that was a fantastic day. I'm Dr. Vincent Fischetti. I'm a professor at Rockefeller University and head of the Laboratory of Bacterial Pathogenesis and Immunology. We've been using antibiotics for about 100 years. And during that time, the bacteria have learned to become resistant to those antibiotics.
Drug-resistant bacteria are one of the most serious public health issues that we face today.
We're losing the ability to treat infections.
It's pretty serious. I mean, there are bugs right now that are resistant to all antibiotics. If you're infected by one of these organisms, you just hope that your body is able to control the infection. If it isn't, you die.
By the year 2050, which is not so far away, we will have more people die from antibiotic-resistant infections than die currently from cancer.
Well, what's happened over the years is actually the overuse of antibiotics. So one of the new weapons that people are using are whole phage. There are 10 to 100 million phage in every gram of soil, every cc of water. There are more phage on Earth than any other biological entity. Phage control the biosphere. They control us. They control the environment because they're controlling the bacteria that are in the environment. The phage infects the bacteria, injects its DNA in the bacteria. That DNA produces more phage. The bacteria explode, releasing the phage progeny, and those phage can now infect other bacteria. Phage are the original antibiotic in a sense. Before antibiotics were developed, we started using phage as a way to control bacterial infections. Just at the same time antibiotics were discovered, then we shifted to antibiotic development as opposed to phage development.